Hello, everyone. Welcome to Rational Science, directly from Frankfurt, Germany. It's 9 o'clock over here, 9 o'clock at night. Anyways, today we have a great day. We're going to be talking about a fellow by the name of Nassim Haramein. And then we're going to move on to general relativity, find out what that's all about. And then we're going to have our science critic. In fact, we're going to analyze general relativity also with him because he raised an issue related to general relativity. And then we're going to deal with the flat earthers one more time because apparently they still failed to understand the question after 5 weeks. 5 weeks, they still don't understand the question. Most of them. I can't say that everybody, but they don't, a lot of them come over here and they don't understand the question. Okay, and then we're going to open up the floor for questions and comments that people made since last time. So let's move on with this gentleman, Nassim Haramein. Who is he? What is he about? And a fellow raised the issue, says Nassim Haramein has calculated a geometric solution for the gravitational field. Uh-huh. And says in his latest paper, Quantum Gravity and the Holographic Mass, he describes gravity. Okay, describes, right? In a classical algebraic way by calculating the density of the space both within and on the outside of the event horizon of a proton. Okay, what is this all about? Well, it's about this gentleman. His name is Nassim Haramein. He's, I think, born in Switzerland of Iranian parents. And apparently he does have some influence from the East in his upbringing, his education, his experience, right? And so let's find out what this is all about. Well, it says that he published a paper. It wasn't so recent. This was in 2013. And I think it's the only paper he published. After 30 years of doing research, this is the best he came up with. So let's look at what he's all about. Here it is. He says quantum gravity and a holographic mass. He published it, and apparently new scientists picked up on it and wrote a little article, and then it was scrapped away. Nobody ever read it again. Okay, so that's the situation with that paper. Okay, nobody's paid any attention. The establishment certainly doesn't bow down to it. Okay, and so what is it that Mr. Nassim or Mr. Haramein talked about in that paper? Here we can synthesize it for you, and that includes also his general thoughts, okay, on physics, if we can call it that, mathematical physics to be more correct, okay, mathemagics as we call it here. And this is a synthesis of his train of thought, his way of thinking, what he's proposing. This is what he concluded after 30 years of investigation. 30 years of doing equations, he finally came up with, with the best equation he could. Okay, so here it is. Okay, why can't I see this? Oh, this is incredible. I can't see what I'm supposed to show you. And I have no idea why. Okay, I'm gonna, that's incredible. I don't know why that doesn't come up. I hope, if, does anyone see that? Because I can't see it on your screen, so if you can see it, let me know, please. But if you can't see it, I'm gonna have to redo this somehow. Let's see. Give me a second here and see if I can get it back. No, I still can't get it. It's invisible. It's like my robe, folks. I can't see it, and I don't know why. Okay, I hope all my other ones are not like that. Okay, so nothing to see. No, I can't see it either, and I have no idea why I can't see it. This is incredible. I hope all my other ones are not the same way. Okay, I don't know what else to do here. Why won't I see this? I have no idea what happened here. Okay. Um, I'm just going to have to read it out. That's all I can do. He says that in that paper, he says he's got an equation, which he calls my equation, and he says the exact gravitational mass of a black hole. That's what he calculated. He's saying his main conclusion is that a proton is a black hole. In fact, all subatomic particles are mini black holes. Okay? He says it's a new theory, also what he's got. And his new theory is all about the ether. And that makes me kind of wonder because the ether has been around for 3,000 years now. So how is it possible that, he cannot, that he's still bringing up the ether after so many centuries? Okay, he calls it the fluid space. In other words, he equates ether with space, and we're going to see that in a little bit as well. And he calls it fluid space. In other words, this ether is moving all around. And let's see if I can put this here. Hopefully this one works. And that's what it looks like, more or less. Okay, that's the ether, and the waving in the ether. Okay, so this is, he's saying it's a new theory. Okay, he's a wave fellow, essentially. And so he's saying that he invented this new theory that's got the fluid ether, which is fluid space. Okay, great. Then he says, he starts out his reasoning, if we can call it that. He says, an atom is mostly empty space because it's equal to 0.9999999 bunch of nines percent of space. Okay, so if that's what an atom is, mostly empty space, he says an atom or matter in general, is pretty much space. They're both approximately equal, space and matter, because an atom is mostly empty space. So he equates something with nothing. Okay, he's going to say that something and nothing are essentially the same. In fact, he says it clearly. He says space, matter, mass, charge, gravity, electromagnetic field. There are no differences between these things. Now, how clear is that? I mean, that's as clear as it gets. Then he says that space-time fluctuates with intense energy. What is that? It's the Planck fluctuations, which are the vacuum energy. And he says that gravity is the fluctuation of the structure of the vacuum. So he got all these notions from his schooling, from the establishment. That's where he gets all this stuff. Okay, fine. He hasn't said anything new. And again, he equates space with matter and all these things. He says they're all the same thing. He never defines any of these terms, nowhere. Okay, so you would think that he's more into business, building a business empire, than he is in talking about physics. Okay, he's also a fan of Mayan. He talks about Mayan secret geometry. So he's a fan of all these. You got several people out there that say that the ancients knew more than we do, and we lost all this knowledge over time. That they knew a lot, and somehow it got lost. You got a lot of people that have these thoughts, that have this opinion about what happened in history. He's a Tesla lover, and let's see if we can put that in there. Hopefully this works. This is Mr. Tesla, okay, and this is what he believed in. So if you want to understand the universe, think in terms of energy, frequency, and vibration, not as solid physical forms. So Mr. Tesla was not into physical, he was into abstractions, okay? And that's what he purported to explain the universe with. He says, if you only know the magnificence of the 3, 6, and 9, mathematical numbers, right? Then you would have the key to the universe. This is what this poor fellow believed in, okay? But I like the next one down here. He seems to have a contradiction. He says, the day science begins to study non-physical phenomena, it will make more progress in 1 decade than in all the previous centuries of its existence. Today's scientists, he continues, says, today's scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality. So on the one hand, he talks about math and abstractions, and on the other one, he criticizes the mathematicians because they went more abstract. They're talking about a lot of math and very little experiments. So he seems to have a contradiction. We don't know if he vouched for math or not in the end. But I like the last one. It says, the gift of mental power comes from God, divine being. And if we concentrate our minds on that truth, we become in tune with his great power. My mother had taught me to seek all truth in the Bible. Okay, so that's good old Nikki for you. And this fellow, Haramein, well, he's in the same boat essentially. You know, I don't know if he says he believes in God and all that, but he is a little transcendental, we can call it, spiritual, right? And it seeps into his work. Okay, you can see it in there. Okay, and finally, he says that he vouches for the holographic structure of space time. What is that all about? Well, let me show you here an example, okay, so that you get an idea what the holographic uh, universe is. This thing that came out of a black hole studying of black holes and string theory, which is what they do. They're trying to unify quantum mechanics with general relativity, the macro world, you know, the world of the cosmos, cosmic world, which includes black holes according to general relativity. And then on the other hand, you have the quantum world, which is all particles. And the way they plan to bring these two irreconcilable disciplines or fields of study together is through the black hole. And what they're studying is all the garbage that falls into a black hole. They say all that matter somehow gets reflected on the surface of the event horizon, which, as a lot of you know, is the region of influence of a black hole, where you still have supposedly the escape velocity of light. Okay, so this is what Haramein is talking about. This is what he vouches for. Okay, let's see if this shows up. Yeah, it does. Okay, his holographic universe. And if you look it up on the Wikipedia, it says the description of a volume of space can be thought of as encoded on a lower dimensional boundary to the region. In other words, you have this 2D universe, and from there you can project a hologram. Okay, this is what they're talking about. This is what they're all the math being done lately, especially by string theorists, is all about. They're trying to find out all the garbage that falls inside a black hole and how it maps onto its surface. Okay, and here you see it on the right. It says the holographic principle was inspired by black hole thermodynamics, which conjectures that the maximum entropy in any region seals with a radius squared and not cubed as might be expected. So they're talking about two-dimensional versus three-dimensional, right? In the case of a black hole, the insight was that the informational content of all the objects that have fallen into the hole might be entirely contained in surface fluctuations of the event horizon. Okay? The holographic principle resolves the black hole information paradox within the framework of string theory. Well, we don't know what this information paradox is and what information has anything to do with physics. Information is a concept. Information is not what you send out. Information is what someone interprets at the receiving end. That's information. And to say that's got something to do with physics, how the world works, how the universe works, you know, how gravity works, well, it's stretching the imagination, I'd say the brain a little bit. These people are doing nonsense. That's what kind of work you're paying for at the universities, and that's what the governments are supporting. Rich people who donate money to the universities and funding a lot of these projects. That's what they're funding. They're funding these people who are just doing equations on the blackboard or wherever, and maybe with their computer or on their desk with pencil or paper, crayons or whatever. And they're doing equations, and their equations have to do with what? With a zero-dimensional singularity. Zero-dimensional singularity, which is what I talked about the other day a little bit, which is, you know, you have Stephen Hawking, and you had another fellow there, an Indian fellow from Oxford, or Cambridge, Oxford, I think it was. And what do they say? They say, yeah, Chandrasekhar proved That's what he got his Nobel Prize for. He proved that a black hole is zero dimensional, collapses to zero size, zero volume, infinite density. So, what matter are they talking about that somehow maps itself onto the 3D or the surface of the event horizon, which is the region of influence of nothing, of a zero-dimensional nothing? You have a nothing there. Why? Because all matter has been crushed out of existence. There is no matter. What is mass? Mass is the quantity of matter or a measure of the quantity of matter. Matter has disappeared. There's no structure whatsoever inside a black hole. It's zero dimensional. There's nothing there. So how can it not have matter, but it has mass in zero dimensional size, in zero dimensional or zero dimensional volume? There's nothing there. And from there they build this this event horizon, which is the region of influence of supposedly of that singularity. It's all nonsense. It's all math. It's got nothing to do with reality. There are no such things as black holes, because a thing is that which has shape, and that which has shape has length, width, and height, especially if it's in physics. You know, it's a real thing. So it's got to be at least three-dimensional. Black hole doesn't meet those specifications. Okay. So before we can talk about some of these things, you know, we have to find out what specifically Mr. Haramein is about. And what he's about is what he tries to peddle out there, because he's really a businessman. He's not into physics at all. He's just trying to make money, like so many others out there. And what does he talk about? Well, he talks about this. He talks about the interconnected universe. And for this, he pulls the Shrine of Sayyida Fatima, and that's in Iran. Again, that's where his folks came from. And so he's got this thing that you can see, it's pretty much interconnected. Okay, so you see all these interconnections. That's why he's got that in his Facebook page. Okay, that's good. What does he interconnect the universe with? You know, as a physicist, you would think that he would try to interconnect the universe somehow, right? So you would think, I mean, if he's talking about connection, right, between atoms, between everything in the universe, he's saying everything is connected. Is he talking about the same thing that I'm talking about when I say the universe is interconnected, physically interconnected? I mean, that's what a physicist talks about, right? Okay, so let's find out. Now, this is what he's talking about. He says, here you have quantum mechanics on the one side, which is all discrete particles, and you would think that he, as a physicist, would be talking about what you see on the right, a connected universe where all atoms are physically interconnected. In other words, what you need to identify is those little lines that unite or that bind any two atoms. And again, we talked a little bit about that last week, so you can look that up. Question that arises is, what connects two atoms, especially one vibrates and affects the other one at a distance? Either you put something in between or you do black magic. Okay, so it can't be both ways. So if you put something in between, we need to know what that something is and what it looks like, you know, identify it for us. And that doesn't mean you've seen it or you tested it. No, it just means you imagine it and you're going to explain whatever you explain your theory with, you're going to explain it with that thing. Okay? And the reason I say this is that interconnectivity in the universe has been around for, I'd say, thousands of years. It's not the first time someone thinks about a universe that is interconnected, interdependent. Here you have two examples. One is the Hindus, okay, and they talk about the interwoven tapestry of cause and effect. And they really are not talking about things. As you can see, they're talking about social and moral. They're talking about the web of life, energy. They're talking about concepts, and they're not interested in the physics part of it. They're trying to tell you how to live. Okay, they're trying to tell you how to behave in society, and for that they start by saying, look, you're supposed to treat nature properly. We need the plants, we need the animals, you know, et cetera, et cetera. It's got to do with a lot of that and very little to do with physics. You won't find a physical object that interconnects the universe in all of Hinduism. And just in case, here's Buddhism, okay, same thing. And here they talk about interdependence through space and time, causality that are interwoven through the universe. Everything is interconnected. Yeah, by what? And they mentioned the fact that quantum mechanics has more or less proven that to them, because they talk about entanglement, and they said, look, if entanglement shows that this atom affects that one, we're pretty much on the same boat. They're saying that everything's interconnected. Yeah, the problem is that no one has figured out, what interconnects us. What physical object is interconnecting the atoms, the universe, the matter in the universe? And no one identified it. Not the Buddhists, not the Hindus, and for sure, no one today. So when Haramein comes in there and says, "Look, the universe is interconnected," he hasn't said something new, unless he puts a physical object in there and shows that what binds two atoms, two pieces of matter, two universes, whatever. Okay, so he's got to put something in there. If he doesn't put anything in there, he hasn't said anything new. He's just repeated what the Hindus and Buddhists have said for centuries. Okay, so here it is. Here's a summary. Let's hope I can see this now. Yeah, this one came out, okay? And he says the following. He says, there is a flow of the energy of the universe inside you. Whoa, that doesn't sound like physics. It sounds more like he's going to sell you something, how to behave, how to be a nice guy, how to treat nature. He's going to talk about stuff that's got nothing to, recommendations, nothing that's got to do with physics. He says everything is connected through this energy. Oh my God. Energy, as we found out the other day, it's a concept. So you can't say you connect something with energy. Then he says space is what's connecting everything. These are statements taken out of his videos, by the way, just like you read them there. Space is what's connecting everything. What do you mean space connects? Space is what separates, not what connects. Space is nothing. But of course, he said space is something, and therefore he's connecting it with this something. What he doesn't do is draw, he doesn't illustrate this something so that we can see what he's talking about when he says that space connects everything. He says space is the thing that connects all things. So he's talking about space as a thing. He says that's the connector, the binding thing, the thing that connects us to everything physically, right? Because I guess he's talking about physics. As one little proton is connected to all other protons in the universe. Spin, the one thing that connects us all. Spin. So spin connects us. Okay, what is he talking about? How can spin connect anything? You spin a top. How does that connect you to the other top? They're both spinning. How are they connected? Then he says space-time is an energy that connects everything. So he's got all these words. He's got it. It's all ether. The electromagnetic or electrostatic field that we see as matter is just a function of the dynamics of that ether. Gravity is a function of that ether. And then again he says space, matters, mass, charge, gravity, electromagnetic field. There are no differences between these things. Okay? They're all connected through quantum fluctuations. So let's see. He says, what are the connections? He says there's energy, space, spin, space-time, ether, and quantum fluctuations. That's what connects everything. None of those are physical objects. So yeah, he finally says, it's really hard to wrap your head around it. Yeah, no kidding. So again, I think Mr. Haramein is into something else. He's into doing business. He's into trying to hit the jackpot by, running his company. He's got a little company in Hawaii over there. And what he wants to do is see if he can convince the world, especially the mathematicians, that he's onto something. Okay, that's what he's up to. And just as a comparison here, you see, this is what we're proposing. We're saying, yeah, we are saying that all atoms are physically interconnected. Okay, and so all those lines that you see there, those are what we call the electromagnetic ropes, and they do bind any two atoms, not like they're pasted to the surface of the atom. It's that the ropes convert into the atom, which converts into a rope, which converts into an atom, and so on down the line. There's a single thread in the entire universe. Everything is, there's one thing only in the universe, which is the thread, the universal thread, and that's what converts into ropes, atoms, ropes, atoms, ropes, atoms, and so on down the line. Okay, so that's what we're proposing. So we do have a physical connector. There is no action at a distance. Okay, so that's the difference. On the other hand, this fellow talks about energy and quantum fluctuations, space, and stuff that is not stuff. That's the difference. Okay, so when he says the connected universe, which is what his sales pitch is for physics, he also does some other stuff out there. Does a little bit of history. He branched off into other line items because I guess he needed to make money to keep his company afloat. And so he branched off into all these other things, but he kept this connected universe, which he's trying to see if he can convince the establishment of. And yeah, if you're going to connect it with abstract concept, you're not doing much of a connection. There's no binding there, no physicality to the whole thing that you're proposing. So this connected word in there is too much. It's not connected at all. He's trying to connect it with abstract concepts, and that's not a connection. Anyways, he's not the only one who's trying to make money. All these people also, not only Haramein, but Cox, Al-Khalili, all these people, they're just trying to make money. None of these are scientists. None of these are physicists. They are all deluded charlatans. That's what they are, and they're making money. That's their only purpose. That's why they're up there. And they're supported by the establishment, okay, because it keeps the ball rolling. And so they just pass on what they learn in college by rote, through authority, through tradition, and they pass that on down to the masses. And what they do is really entertainment. They don't do physics, they do entertainment. Okay? So that's the world in which we live. That's what so-called physics, mathematical physics, mathematics, that's what it's evolved into. That's how it developed. That's what we have today. And for the last 60 years, there hasn't been anything new. In quantum, nothing changed. They still have particles. They want to call these particles, no longer they call them particles like discrete particles, nothing like that. Now they're called fields. And a particle is really an excited field locally. And when you measure it, then you measure it as a particle. When you don't measure it, you don't look at it, you don't see it, you don't touch it, then it becomes a field back again. So that's the way they treat that. How about general relativity? Well, in the 60s, you had Roger Penrose and Stephen Hawking, and they popularized a thought that had already been coming from 1915, which was the black hole. They popularized the black hole. Well, when people got tired of that I think towards the end of the 80s or 90s, I think it was 98. I think in 98, they came up with dark matter. Einstein never heard of that. That came much later. And so today we have dark matter. And since then, there's been nothing new. It's all the same nonsense. They just regurgitate. All these people, they say exactly the same thing. You saw one, you heard them all. There's no difference between any of these people. Maybe one guy says it a little differently than the other, gives you a different example, a different analogy, fine. They're a little different in that sense. But they all say, the bottom line when you open the onion all the way to the end, they all say the same thing. And it's black holes, dark matter, until you get sick of it, okay? Dark energy, obviously, parallel universes, Big Bang, you're going to hear of that, about all that till the end of time. Quantum mechanics, same nonsense. Particles, it can be at two places at once. You have entanglement, you have superposition, the same old nonsense. They all say the same thing. You see one, you've seen them all. So there's nothing new. And in that sense, you could say physics, mathematical physics, is at a dead end. What more equations do we need? We need to figure out how gravity works. We need to figure out, how this magnet attracts that one. Okay, that's what we need to figure out. That's what people want to understand. That's what people want to do. And we don't have that. After 3,000 years or maybe more, nobody understands that yet. Nobody can, in mathematics, okay, mathematical physics can explain to you how a magnet attracts another, or how gravity works. Okay, fellow says in relation to that, he's two fellows, and this gives you an idea of what the state of a lot of people is out there. They become atheists in mathematical physics. They don't like all that garbage they hear about Big Bang and black holes and dark matter. They don't understand any of it. They hear the same thing over and over. They want to search for clues for how this universe works, and they can't find it. They can't find it out there in mathematical physics, the official version, right? And so these two fellows, one says, science is a religious thing. It's been used to replace divining the future by inspecting chicken and your mission is to find a replacement that fulfills that function. Yeah, someone's religion. We've been doing that for a while. It's all magic and BS. Okay, and another fellow says, scientists don't know nothing. Neither does anyone else. You know, people have lost hope, and they say, you know, it's all nonsense. What are these people feeding us? And, you know, these are usually laymen, and they don't understand anything of what's going on out there, and they can't get an understanding. Maybe they're trying to find something. They're trying to find out how this universe works, how does gravity work, how does magnetism work, electricity, and so on, light. And these people just keep giving them the runaround, mathematical equations and so on. So they're sick of all that, okay? And here's another fella. He says something along those lines. He criticizes me, and that's good. I like to put these people up here, okay? Fell on the other side. When I don't have one problem, I have the other. Give me a second here. Let me get it up there again. Okay, here it goes, if I get it right. Okay, he says, we are all in the same boat, Bill. Even you, as we fight the stupid establishment, okay? Your rope hypothesis will only be contemplated by flat earthers. And I guess he meant also the electric universes, right? No serious scientist will ever respond to any of your work. They have vested interest in what is said to be now. Flat earthers can think outside the box. No doubt about that. Just like the electric universe people can, okay? Stop talking down to the people that try to learn. You are going to need them. Well, what can I say? I say that, you know, I don't need these people. I don't need them not because the establishment is irrational. I'm going to go with more irrationality coming out of the flat earthers and the electric universe and the John Chappell Society, also another group there. All these groups are irrational. They don't have anything rational in them. So it's not like I'm going to say, okay, I'm going to unite with all my enemies, well, the enemies of my enemies. You know, it doesn't work that way in science. In science, I'm for myself. Okay, it's like the Three Stooges. You know, say all for one, one for all, imitating at the what is it? The Three Musketeers. And Curly says, I'm for myself. And I'm for myself, okay? I'm like Curly, okay? Yeah, I don't take I don't take all these BS from all these people, from the electric universers and flat earthers, just because, you know, I'm fighting the establishment. Okay, I'm fighting the establishment, but I do it on my own. I don't need these people. Certainly, I don't want to be associated with them. And here's a reason why. Here's the electric universe, okay? It's irrational, completely. Gravity, they say, is electricity. Absolute nonsense. In that sense, the establishment has it correctly. Gravity is gravity. It's not electricity. And electricity has nothing to do with gravity and vice versa. They can't define electricity. I did a little bit of that last time. Here it is real quick. Okay, you go to the Thunderbolts and they say, what is electricity? And it says it's a catch-all term that describes several different phenomena, but a fellow says consensus opinion is lacking precision. Reducing electric terminology into smaller units is impossible because, why? It lies at the bottom of the lexical well. In other words, he says it's just semantics. Okay. And then he says electricity, which we define as the flow of electric charge, particles of charge. But then he has the flow, it's traveling, you know, travels through the circuit. And he says electromagnetic energy flows and electricity moves through the DC circuit. So if electricity is the flow of whatever, now we have the flow of flow that's moving. And here you have what it is really. It's a river. You know, that's what electricity is. According to these people. And if it's the river has two components, okay? And what are they? Well, you have the flow and you have the water. So you can say the water flows, okay? And that's what a river is. But you cannot say the river flows, not in physics. You can do that in ordinary speech, but not in physics. In physics, you have to name the object. In this case, it's the water. And you can say river is water plus flow. Okay, so now we understand that. That's what electricity is according to the electric universe. But see, they say electricity is it's either the flow or the water. Which one is electricity? And no, electricity is both, because electricity is like a river according to the establishment and according to the electric universe. Okay, it's a flow of particles. So either you can say the particle flows and electricity is the particle, or electricity is the flow, or electricity is the particle flows. Okay, in that sense, electricity is a river. But then the object, the thing that is flowing, is the particle. Okay, so let's not lose sight of that. The particle is what is flowing. That's what we're going to concentrate on. We want to know what the physical object that is flowing is. And of course, they can't do that because they can't even start with their atom. They don't have an atom in the electric universe. They still use Niels Bohr and Rutherford's atom, planetary atom, you know, the little proton and the little electron flowing around. And the only question they got to answer before they talk about electricity is, why doesn't the little electron fall to the nucleus, to the proton? Why doesn't it spontaneously fly away? In fact, that was what triggered quantum mechanics, the fact that they could not explain why the electron doesn't spiral into the nucleus. That's what started quantum mechanics. And to this day, we still have no answer to that. The only answer that Mr. Bohr gave, he says, look, the little bead falls between energy levels back and forth, these regions, right? And it doesn't fall all the way to the nucleus, it just falls to the lower energy level, then it rises to the energy to the upper energy level, and it's within these orbitals. What is an orbital? A concept. It's just a region. We want to know if it's a wall. In fact, it's got to be a wall, one, for it to prevent it from flying out, and the other one from flying in, right? It's two nested walls, spherical walls that encapsulate the proton. We can understand that. But then the question would be, why does the little bead go back and forth, jumping between these two walls? Then you can more or less conceptualize what the atom looks like. That's not what these people are saying. They're saying we have two regions, and the electron just goes back and forth between these two regions. We don't know why it doesn't fall to the nucleus. We don't know why it doesn't fly out of the solar system, you know, or out of whatever to the other side of the universe. We have no idea from quantum mechanics. Okay, so they invoke electric universe invokes the planetary model, which is absolute nonsense. And until they can get an atom, they can't even talk about electricity, let alone the fact that they can't define it and tell us that it's the flow of flows, okay, and all that stuff. They build their continuous filaments with this discrete atom. You know, they talk about the universe also somewhat being interconnected with all these filaments. Well, again, it's one-way electron flow. And that's how they plan to connect everything, you know, bind everything. Pull, I guess, I don't know. And the question there is also if electricity flows from, you know, the negative pole to the positive flow. You have all these electrons, negative electrons flowing to the positive pole. Which star is the positive? Which one's the negative? You know, do they switch back and forth, alternating current? I mean, a lot of questions that these people don't answer. They treat plasma as a physical object. Plasma is not a physical object under any definition, whether it's the fourth state of matter. There's no physical object, standalone object called fourth state of matter. So that already eliminates. So never use that definition to say that plasma is a fourth state of matter, because you lost already. You don't even realize it. There's no physical object called fourth state of matter, so you cannot say plasma is the fourth state of matter, and then it's also an object, a thing. Okay, so that's the first thing they don't understand. And they say, Bill, you're doing semantics. No, it's called physics, laying the foundations of physics. You have to start with language so that we can communicate. Okay, you can't say, well, I don't care about semantics. I came here to do physics. That's the way these people think, or don't. And then the other issue is that plasma is a dynamic concept. It's not even a physical object. It's a dynamic concept. And again, we have the flowing river. You know, is the river the water, the flow, or the flow of water? Is it both? And plasma is an atom that's been ionized. Ionized is a verb, not an adjective. You could use it as an adjective. In fact, we use it as an adjective adverb, really, because it's qualifying motion. Ionized means you're going to remove, according to the establishment, according to the electric universe, you're going to remove an electron from an atom. So you're pulling something out. That's not a physical object. You can't say, I pulled a banana out of the pile, and that pulling a banana is a physical object. And that's what plasma is. Plasma is pull an electron from an atom. That's not a physical object. You can say the electron is a physical object, and you can say the atom is a physical object. We can accept that. We cannot say that pulling an electron is a standalone physical object. Okay? Plasma is a dynamic concept. So you can't say plasma does this and plasma does that because it's already doing it before you even mention the word. So it's neither the fourth state of matter is not a physical object, and pulling an electron is not a physical object. Okay? In both cases, we have verbs. Okay, they also use the ether, the vortex, nonsense. A lot of them, not everybody. Okay, they introduce mathematical physics jargon just casually. You know, here they criticize the establishment, then they go out there and borrow all their words. Charge, field, wave. They use all these words. You know, none of them are physical objects. You can't use any of those words in science, not in physics. You can use them in mathematics. In the religion of mathematics, you can say, oh, it's a field. Oh, it's a wave. Oh, it's a charge. You can't use those words in science. Okay, those are concepts. You can't say that charge is a standalone physical object. No, charge is 1.6 times 10 to the minus 19 coulombs. That's what charge is. It's a number. And a wave is what? Is a standing thing? No, you can say water waves, flag waves. What's the object? Flag. What's the object? Water. So when you see the electromagnetic wave, what is it that it's waving? And some people say nothing is waving, that it doesn't need a medium for it to be waving. Then how can you conceptualize the waving of nothing? What is waving? Space, like Haramein said? Space is what's waving. Nothing is waving. Please draw it. Okay? And so you can't use that language that these people have borrowed from mathematical physics. And they propose experiments. We don't do experiments in science. Yeah, just like you heard. Let me repeat it just in case you say, well, it was a slip of the tongue. No, we don't do experiments in science. Is that clear? We explain experiments. We explain observations. We don't gawk and say, oh, I did an experiment. I'm a scientist. Oh, I observed. I'm a scientist. No, the fact that you, drooled and gawked, doesn't make you a scientist. It's when you come to the conference and you explain the results, what you learned, then you're a scientist. But to say that you did an experiment, here, I do experiments all the time. I let the spoon let go of it and it falls to the ground. Does that make me a scientist because I just did an experiment? Oh, sorry, I got to do it repeatable, 2 times at least, okay? So it's a repeatable experiment. There, I'm a scientist. No, we don't do experiments. Gophers do experiments. In fact, where I worked in the fabs, a lot of operators did the experiments for us. We collected the data. We had to analyze the data. That's where the scientist intervenes. But to do an experiment, a lot of people can do experiments. Just need hands and eyes for that. Sometimes not even eyes. Anyways, one thing that they have is that the electric universe, they censor critics. In this sense, they give out a little bit of the medicine that they take. They hate the establishment because the establishment censors them, and they do the same thing to everybody else. So once these organizations are built up, they do censorship as well. So that's the story for Mr. Haramein. Haramein is simply a businessman who put a little shop over there in, I think it's Honolulu, he's in Hawaii. And what he tries to do is he's diversified. He's got lots of line items there. But the one he's trying to push, because that's his that's what he studied, mathematics, right? He's trying to convince the establishment that he's got something new and that he can help with all this string theory and the understanding of how this universe works, especially gravity, by saying that a proton is just a tiny black hole, and he's going to fall into this black hole, and he's going to try to map it against the inside, the event horizon. He's going to map whatever garbage fell into the black hole, right? And no one addresses the key issue, which is a black hole is nothing, zero dimensional, as proven by Mr. Chandrasekhar, for which he won the Nobel Prize. Therefore, there's nothing there. And if you have no matter, you have no mass. So a black hole also has no mass, no size, no nothing. Black hole is the definition of nothing, okay, of empty space. Okay, let's move on to general relativity. Okay, here we have the starting point, very straightforward. Okay, general relativity says that gravity is the warpage of time, bending of time. That's what they say is gravity. Okay, so here it is illustrated for you. Okay, we have the seconds. And the reason the Earth doesn't fly out of the solar system is because there's a wall of seconds, a wall of minutes, a wall of years, maybe decades, centuries, that prevents the Earth from flying out of there. Okay, I did it with seconds because I don't really know which unit they're using. Okay, so all I can tell you is that this is what general relativity says. It says that time is warped. Okay, there's this four-dimensional entity. One of the legs of that entity is known as time. It's measured in seconds. It's you could say a parameter that is very important to mathematical physics. And what they do, they bend this time. They call it a dimension, right? And this bent dimension apparently serves as a wall to the Earth, so the Earth doesn't fly out of the solar system because the seconds are warped. Okay, actually, that's not totally true because it comes from Einstein's equation. Okay, and Einstein's equation is a field equation. Let me remove this here. It's a field equation. Okay, what is a field? Well, as we saw a minute ago, a field is just a bunch of numbers. It's a set of numbers. And what, in the case of gravity, but really all fields for that matter, all they're talking about is that numbers decrease, or you could say the force becomes weaker the farther you get away from ground zero. That's the notion of a field. It's a bunch of numbers, a set of numbers, spherical shell, encapsulating ground zero, right? So it's a spherical shell of different strengths of whatever, of electricity, of magnetism, gravity. So the farther away you get from ground zero, from the center point, whatever it is, could be the Earth for gravity, it could be the Earth for magnetism, and so on. It could be a charge, a little stick of electricity, and from there, electricity, magnetism, gravity all decreases in strength as you get farther away. So a field is just a bunch of numbers that they can measure. They say, well, the field strength here is so much, and over here, farther out, it's weaker, and closer to the thing, it's stronger. That's what a field is. Okay, so here it is. Let's put that same thing. First, let's find out what the definition of field is again here. We have field, a quantity, okay, represented by a number that has a value for each point in space and time. So what is a field? It's a quantity. It's a number, okay? It's represented by a number that has value. We're talking all numbers, right? Amounts, quantities, right? For each point, location, okay, in space and time. So that's what a field is. And so the question here is, that's, you see it there illustrated, that's what a field is, a bunch of numbers. They get weaker and weaker. I illustrated here becoming smaller and smaller, okay? That's what a field is, a bunch of numbers surrounding an object. That's what it is. Whether you talk about a gravitational field, electric field, or magnetic field, that's what a field is. Okay, so let's illustrate this with the Earth. Let's find out what prevents the Earth from flying out. I said a minute ago that it was time. You've got warpage of time. Could be the seconds are warped. They turn these things into physical objects. These words, right? They turn them into physical objects. And here you have it. Here's the field also around the Earth. Okay, so the Earth goes around, and what you have is these numbers. and they're vibrating because the fields is vibrating numbers. They wiggle back and forth, they up and down in different directions. Okay, so it's not like the Earth just goes around and circles around nothing, right? Or on top of nothing. There is something there, and they call it a field. And so the first question you should ask yourself is, hold it, how does field, what does field have to do with time? Because if on the one hand you have time serving as a wall, as a dimension that is curved around and prevents the Earth from flying out, because they're saying it's warp space time, right? That prevents the Earth from flying outwards. Then how does a field, which is a bunch of numbers that just decrease in strength from ground zero, how does one thing have anything to do with the other? How do you reconcile field with time? That's the question. Okay, because field is just a bunch of numbers that are weaker as you get out, right? From, say, the sun in this case. The sun is the center of our system here. We're talking about the sun and the earth, right? The center of the sun is where the great, biggest point for the field is, the strongest point. And as you get out, it gets weaker and weaker and weaker all the way to the earth. Okay, so the gravitational field gets weaker as it gets farther away from the sun until you get to the earth, and even weaker as you get farther out. Great. What does that have to do with the wall of time, warp space time, right? That serves as the depression along which the earth rolls around like a little ball on a roulette. That's the question. So what does field have to do with time? Which one is the true mechanism? They say Einstein's is a field theory. And then on the other hand, they say warp time is what prevents the earth from flying out. So, you try to make sense of that. I don't think you can make sense of either one of them, but they seem like they're contradicting each other. Okay, in order to get to how do we come up with all this nonsense? General relativity, poppycock. Well, we got to start all the way to Newton, 17th century, okay? So let's bring Mr. Newton in, and he came up with an equation. Really, he wasn't the originator of the equation. It was the French who later on developed the equation. He's given the credit because he's the guy who said mass divided by distance squared. In other words, you have two masses, two objects, and we're looking at the weight, the mass of each one, right? And it's inversely proportional to the square of the distance. That's essentially what Newton said. He didn't even have the gravitational constant G at the time. Okay, he just said, look, there's this inverse relation to distance. Okay, between the masses. Okay, and so this is what it looks like. Okay, here's Newton's equation. It says force equals gravitational constant G, mass, multiply those divided by distance squared, and that gives you the gravitational force. Okay, two masses separated by distance. The big problem is, he said, hypothesis non fingo. He wrote in Latin. Okay, they did in those days. That was the English of those days. Everybody who was educated would talk or write in Latin. Turns out, he says, hypothesis non fingo, meaning he doesn't have any theory. He doesn't have an explanation for how that works. Okay, what he had is a description, mathematical description, but not a theory. He did not have an explanation, a physical interpretation of how gravity works. And to this day, no one in mathematical physics has one. And he was a particle man. He believed in the ether also. And so, he could not imagine how particles going out from the earth and going out from the sun could attract one another. So he said, he couldn't explain this. He says, I have no explanation for how this works. And here's his words, and they come from the Principia and from a letter he sent to Bentley. Okay, and the first one he says in the letter to Bentley, he says that gravity should be essential to matter, so that one body may act upon another at a distance through a vacuum without the mediation of anything else. Okay, without a mediator, right? By and through which their action and force may be conveyed from one to another, is to me so great an absurdity that I believe no man who has competent faculty of thinking can ever fall into it. He continues, says, gravity must be caused by an agent acting constantly according to certain laws. Okay, so there's got to be a mediator, an agent. Okay, he said there's got to be something in there. Okay, what was the problem? He couldn't see or touch anything between two atoms or between two objects. So he says gravity must be caused by an agent acting constantly according to certain laws, but whether this agent is material or immaterial, I have left open to the consideration of my readers. So he says, I have no theory. I'll let you figure it out. You come up with whatever you want, but I'm just going to describe, essentially. In other words, he was not a theorist. All he was is a mathematician. What do mathematicians do? Well, they describe. They can only describe. That's all that mathematics can do. It cannot explain anything. And that's why Newton could not explain a single thing. And then he continued in Principia, he says, and this is the version of 1713, he also wrote in 1687, I have not as yet been able to discover the reason for these properties of gravity from phenomena, and I do not feign hypothesis. Again, no, fingo non hypothesis, right? And he says hypothesis, whether metaphysical or physical, listen to this, whether of occult qualities or mechanical, have no place in experimental philosophy, meaning mathematics. Okay, so here you can see his what happened in the 17th century so-called scientific revolution. They said, look, we don't care about the explanation, we don't care about the physical interpretation, we don't care about any of that. What we care about is experiments, right? In experimental philosophy, he said, we care about experiments. We care about describing them mathematically, and that's it, measurement. But he had no explanation. He said, well, we don't care about that. Okay? He said, it is enough that gravity does really exist and act according to the laws which we have explained. No, you haven't explained anything, Newt. You've only described. Explanation means that you can explain, give us a physical interpretation, right, of the causes and mechanism. And obviously he was not able to do that. And so he says that all he can do is describe essentially the motions of the celestial objects and the sea, etc. So all that Newt could do was describe. Okay, that was his folly. He says, look, all I can do is describe. And he called it an explanation, which it wasn't. To this day, we have no explanation forthcoming from the establishment, mathematical establishment, and I recommend that you do not hold your breath, okay? Okay, just in case, you know, he used particles, and particles can only push. But even if you replace them with, like, Robert Hooke's waves, right? He's the guy who came up first with the longitudinal waves. Later, they were converted into transverse waves by in the early 19th century folks, okay? And Fresnel and Fizeau and some of these other Frenchmen there. And here you see what happens with a wave. Wave only pushes. Okay, there is no wave that attracts. You cannot attract with a wave. Wave can only push. So whether you use particles or waves, you're going to be pushing. Okay, and so the question is, how do you produce pull with push? Okay, and that's when Mr. Einstein comes in. He changed a little bit, quite a bit, you know, the physical interpretation of gravity. And he got rid of Newton. He said, look, yeah, this thing that you got, force, particles, waves, none of those work really. We do it differently in general relativity. How do they do it? They said, he said, he did it with this field, this supposedly medium that pervades everything in the universe. In other words, space is itself a physical medium in general relativity. They call it space-time. Before then, they call it the ether. It's the same nonsense, just different words. Essentially, he says there's this medium. This medium is made of particles, just like the ether is, no different. And what are those particles? They're really locations of where you're going to measure something. Okay, and that's where quantum intersects, you could say, with general relativity, with space-time. Okay, so here's Einstein. He changed that. He's going to do it with push, but it's listen to how he does his push gravity. He does it a little differently than Newton. Newton drew particles back and forth. He says, I can't explain it with that. How does Einstein explain it? And here it gives you an idea. He's got this equation. Left-hand side is space-time curvature. Right-hand side is the source. In other words, the source, in this case, bends space-time downwards. It's bending time downwards. And because of that, space-time is warped, and that forces the moon to roll around the Earth. Okay, so that's essentially the physical interpretation. We do not care at all about Einstein's equation. He can do all the equations he wants. When he comes into physics, he's got to explain how gravity works. And this is his explanation. This is the explanation of relativity. And we take it literally. We don't take it as an analogy at all. It either is or it ain't. You can't say this is just an analogy. No, if it's an analogy of what? If you're going to later on say, well, I deny all of this, there is no depression, there is no moon going around this depression, and the Earth doesn't push a canvas downwards, then what was the purpose of the analogy if you're later on going to deny it? Either this is or it ain't. And you have a statement from Mr. Wheeler, John Wheeler, who synthesizes, says, space-time tells matter how to move, matter tells space-time how to curve. That's essentially what the equation says. That's what it tells us. Okay? Okay, what happened was that, well, you have all the mathematicians. This was in 1915 when Einstein came up with his field equation. And all the mathematicians, well, not all of them, in fact, very few at the first, did like his idea, said it's different. Why? They liked it because suddenly they had a different physical interpretation for how gravity works. And that's great. If you've got a better interpretation, let's look at it, And one of the things that eventually came out is that Einstein's equation was a little more accurate than Newton's, especially when they had to describe the orbit of Mercury. Okay, whereas Newton has two masses separated by distance, in this case, Mercury and the Sun. Einstein's equation, what they did, the field equations, what they did was they looked at a point mass that's going around the Sun. So we have a point mass going around another mass. That's all they looked at. They don't look at objects. They don't look at things. They said that we have a point mass going around, and what Einstein's equation does is it describes the itinerary of that little point mass. And so it turns out that Mercury's perihelion shift, let's say this right, Mercury's perihelion would shift over time. It would, shift and form like a rosetta over many orbits. And because of that, they weren't able to explain that with Newton's equation. They were able to explain it a little, or describe it really, with Einstein's equation. And so they said, well, Einstein's equation is a little more accurate than Newton. It's a little closer. It wasn't perfect either, but it got closer. A lot of people say that he fudged the numbers to get them closer. Fine, that's, opinions there. But the point is that the mathematicians later on, when they finally bought into his theory, his description, his field equation, the main reason was that, or one of the main reasons was that it was more accurate than Newton's. Okay, and here's an analogy. Okay, here we have two mathematicians. Mathematician A, he comes up with an equation and he says, look, I measured, I did my calculations, and he ends up with a straight line. That's his equation describes a straight line. Another mathematician, he's a little more sophisticated maybe, and he goes in there, he measures, he does his calculation, he says, well, it's not quite a straight line, I think it's like a curvature. So now he gets the Nobel Prize. Why? Because he's got a more accurate equation that reflects what they've been studying. But see, all they're doing is ad hoc stuff. They're tailoring the equations to their measurements. And once they discover that the measurement is not exactly what they thought it was, and they perfect the measurement, they say, oh, we made an advance. And all they're doing is tailoring the math to what they observe. So mathematics is a tautology as it's applied to mathematical physics. It's a tautology. All they do is measure and come up with an equation. And once they have that equation, boy, it had better meet, they say we can predict. Yeah, of course you can predict. You can predict because you did it 100 times. You finally tweak the equation to the point where it matches exactly, and now you can say, oh, we can predict. And so what? You still haven't explained anything. You haven't explained the cause of gravity. You haven't explained the cause of magnetism, but you can predict that a magnet attracts another, or that, this spoon will fall to the table. Great, you can predict. And you can tell me exactly how fast and what the acceleration is and get all the numbers right, but you still cannot tell me what the cause of gravity is. Okay, and so that's where we stand today, and that's what they dismiss as philosophy. Okay, um, here we have one of the things that Einstein apparently explained, and it's the Mercury-perihelion shift. You can see that the um, orbit is shifting over time. That's more or less what's happening with Mercury's perihelion. And they thought there was, originally they thought Leverrier was one of the fellows, a French guy who discovered Neptune. He thought, oh, same thing. We have a planet there somewhere between the Mercury and the Sun, and they called it Vulcan. And they were looking for this planet over decades. They finally gave up. They said, there is no planet there. We can't find it no matter what we do. And Einstein came up with his equation and said, oh, I can explain it. In other words, describe it. I can describe the orbit of Mercury better than Newton, and with that they said, oh, okay, now we like it because not only could Einstein describe it, the orbit, better, but he also, on top of that, he was able to do a second thing, which was this here, which is happened 4 years after his equation. He came up with his equation at the end of 1915, and then by 1919, Mr. Eddington, head honcho over there in England, right? Merry old England. And he came up with this. He was able to prove Einstein's prediction that light curves around the sun during an eclipse. And Eddington gave some kudos to Einstein, and the New York Times picked it up. And from that time, Einstein became a household word. Okay? Everybody knew Einstein after that because he had predicted the curvature of the sun, of the light around the sun. Okay. Okay, but how does Einstein do his gravity? Well, he does it also through push. Okay, but it's a funny way he does push, and here it is. Okay, I want you to see this. This is how gravity in general relativity is done through push. Okay, so how do you pull with push? Here you'll see it. Okay, first you build this thing, a bowl, and you push it down with that green ball, whatever that green ball, so it weighs it downwards. So the ball is weighing down. It means it's pushing, okay, the flexible, the malleable green bowl downwards, okay, and this compels or induces something to go around the edge of the bowl, okay. And so what does that little thing do, the little red ball? Well, it's pushing outwards. So in both cases you have push. You have push downwards and push sideways. And the only reason Einstein could get away with it is that you have a continuous bowl. Okay, so that was his insight, the fact that he's got a continuous object, which is the bowl in this case, but he's doing it through push. He pushes downwards and outwards, and that's how he's going to explain gravity. Okay, so it's important to know that unlike Newton, who said, look, we have particles going back and forth, force. Einstein said, no, we have mass weighing down, right? Meaning it's going to push the canvas downwards, and the other one's going to push towards the side of the bowl, just like a roulette. But then the issue is, why does the green ball, push downwards? So good old Einstein is invoking gravity, force, right? Newton's force, Newton's gravity, to explain gravity. Okay, that's what he's doing. He's saying gravity is like this. Look, we have a force to start out with that pushes the canvas downwards. Okay, that's push, and then the other one has no other choice but to roll around. Why does it fall inside the hole? Well, we don't know. It just keeps rolling around forever. And of course, you cannot explain this with a three-body system. You can only explain it with two. Okay, that's another issue. Okay, and because of that, you have, these people who say that, you have all these ripples, these waves that go along space time, and they say those cannot travel faster than the speed of light because the speed of light is the limit, the speed limit of the universe, and so no wave can travel faster. And they have but a wave travels one way also. So they discovered a few years ago, a couple years ago, they discovered gravitational waves from two black holes that allegedly collided. They got a Nobel for all that stuff. And the question is, that wave comes one way. So let's assume two black holes collide. Lots of mass, great, let's concede all that. So two black holes, heavy as the entire universe, they collide and they create waves. Great. These waves come towards us. How does that produce attraction towards the two black holes? That's what we have no idea of. And so here you have, because the mathematicians say, look, if the sun were to disappear, all these gravitational waves, they can't travel faster than light, so we would not fly out immediately from the solar system, us being the Earth, right? We would not fly out instantly. It would take 8 minutes for all those waves to travel to the Earth along space time. So here you're rolling around time, right? Because time doesn't is curved and does not allow the Earth to fly outwards, right? Time is curved there. And here you have these waves that come along space time, I guess. Time is all the way to the Earth, to the sun. They come along there no faster than the speed of light, and until that sun disappears and there's no mass weighing down the canvas, we don't fly out. And this is an illustration of that. Here you see it, okay? So according to relativity, if the sun were to disappear, it would take 8 minutes for the Earth to fly out of the solar system because gravity cannot travel faster than light. Okay, so this is the notion that we have today, and there you have space-time, all those, that canvas there, that space-time, you can see the waves coming towards the Earth. Okay, but what's the issue? The issue is that they treat space and time as physical objects, meaning time is a physical object because it's one of the legs of space-time, four-dimensional space-time. Okay, and so, well, there you have it. That's the party line. That's what you will learn if you go to the university, and now you're an expert in general relativity. There's no more than that for the theory, for the explanation, for the physical interpretation. We don't care about the math. They can do all the math they want. When they come to the conference, we want to explain the physical mechanism. Okay, and so we don't need to curve space-time, okay, like Mr. Eddington did, with the light moving around the sun. And here's a comparison between what he did and how we do it under the rope model, okay. According to him, light curves around the sun, so we have star far away, and that light from that star curves around the corona of the sun. Okay, that's the way Einstein saw it. Why does it curve? Because it follows the curved path of space-time, meaning time is a physical object, time is curved, and light travels along or slides along, rolls along, I don't know, along this curved path of time. How do we do it? Well, we do it a little differently. We do it all with straight lines. We say that light is mediated by a rope, which is under tension between any two atoms. So it's always taut. That rope is always taut. Okay. And what happens is that light propagates along this rope from one atom to the next. And from the star very far away to an atom that forms the corona of the sun, it is relayed from that star, from that atom that's doing its quantum jump. It's relayed from there to the Earth. In other words, you do it all with straight lines. You have one straight line from an atom in the star to an atom that forms the corona of the sun, and that atom is titillating. It's expanding and contracting, doing its quantum jump, and from there it relays that same impulse all the way to your eye, and that's why we see it. So we do it all with straight lines, no curvature. Light never curves. Only after 10 beer, it might curve, but otherwise, I don't think so. Okay, so what do we have? Let's compare here. We're going to compare what general relativity proposes. It's got this canvas, which is space-time, supposedly four-dimensional. They put it in a three-dimensional version because they cannot illustrate what they're talking about, and you have to accept it as is. And here's the rope model of the same thing, okay? Here you see it. We say that all atoms of the sun are interconnected with all atoms of the earth, and the sun essentially swings the earth around itself by these ropes that physically connect every single atom of both objects. Okay, so that's it. You can get an idea from there how easy it is. The reason the earth doesn't slow down significantly, at least, is because space is nothing. So the earth has no way of rubbing its elbow against the space because there's nothing there. Space is nothing. It's not a thing like in relativity. Okay, in relativity, space is a physical object. It's the ether. They call it space-time. They gave it 4 dimensions. They say it's unimaginable. They go through all this rigmarole. Under rope, it's very simple. It's just the ropes connecting every atom, and there is no such thing as space. Space is nothing, and so the Earth has no friction with space, and that's why it rolls around forever, pretty much, unless there are other objects, okay, that are affecting the Earth, like other planets and other things that are out there in space. Okay, you say, where did you get this notion, Bill, that we're interconnected, that the Earth is connected to the sun, that the that the moon is connected to the Earth? Well, I showed this the other day. I'm going to show it one more time. If you listen carefully, maybe you learn something. Okay, here it goes. Okay, this is Mr. Brian Greene, and he's going to tell us how the moon is connected to the Earth.
How does gravity actually work? How does the Earth pull on the moon across hundreds of thousands of miles of empty space? They behave as if they're connected by some kind of invisible rope.
They behave as if they're connected by some kind of invisible rope. They behave as if they're connected by some kind of invisible rope.
But everyone knew that wasn't true.
Okay, so what did Mr. Greene say? He says that it's like as if we're connected to the moon by an invisible rope, but that obviously cannot be so. Why? Because they had the wrong definition, or an irrational definition, which they still have, of the word object. They think an object is that which you can see or touch, so they go to the lab and they say, let's run an experiment to see and touch the mediator of gravity, the mediator of magnetism. Now, you can't do that. You can't see or touch the mediators that Mother Nature uses. They're invisible, intangible. Yes, there are invisible, intangible objects. Noumena, that we talked about a couple weeks ago. Yeah, these noumena, they're invisible, intangible objects. And they're like, well, one of the so-called philosophers said, noumena are objects of the mind. In other words, you have to visualize them. You have to imagine them. You can't go there and see and touch them, okay? But if you make the assumption that those invisible, intangible objects, mediators, are there, then you can explain the universe very easily. It's only when you do black magic and you say everything is action at a distance. Entanglement, the gluon that connects 2 quarks, they do it all through action at a distance, and gravity. You have all these action at a distance, and yeah, if you're going to do action at a distance, you're doing black magic. Okay, so here you have another testimony of how everything is interconnected. I showed this last time as well, so here it goes one more time. Pay attention. Here you have Mr. Richard Muller from Berkeley, and he tells you how it is.
What's the force of gravity on me? It's the pull of the Earth on my body. So, for example, if you have the Earth with its big mass here, and you have you with your little mass here, that every atom on the Earth is pulling on every atom of you. You're also pulling on it. On the other hand, there are a lot of atoms here you're pulling on. You're pulling on all of them. The amazing thing about gravity is it goes right through things.
Okay, so we're all connected. Every atom in the universe is connected to all other atoms. You're connected to every atom on Earth physically. Otherwise, you wouldn't be pulling on every atom on Earth, and every atom on Earth wouldn't be pulling on every atom of your body. And until you get that through your thick skull, you're going to be doing black magic, because you're saying that all these things happen through action at a distance with no mediator. Why? Because you can't see or touch it. That's the whole issue. That is the whole issue. Once you concede that Mother Nature works with invisible, intangible mediators, then you can understand how the universe works. And you forget about all the nonsense that all these mathematicians have been doing since the days of the Greek. Okay? Okay, here's a situation. You see this, okay? You go out there in the middle of the field and you see this, okay? You see a fellow pulling on a donkey, but you can't see the mediator. You're too far away. You say, how is he pulling on the donkey? Is it black magic? He just goes like this and the donkey comes towards him? Okay, so what are you going to use? Are you going to use stones, rocks, pebbles? Are you going to throw, is that how you're going to pull on the donkey? You're going to do it the Newtonian way. You're going to do it by throwing stones at it, force. You're going to push stones to the face of the donkey, and that's how you pull them. And or are you going to do it maybe with waves? Here's a different way of doing it. This is the wave. Again, the waves go outwards. How is it that you pull with waves? Which is one of the ways that general relativity offers. They say that waves travel along space-time. So, okay, so you have waves traveling in space-time. Let's concede all that. Let's grant those hypotheses. So how does the fact that the wave goes outward pull the donkey inwards? Okay. Now here's a fourth way that you can ponder, and that's using a rope. And you just pull on the donkey. Now wasn't that so simple? Okay. So you have to decide, what mechanism you're going to use to produce gravity. And again, the issue there is, what is the physical mediator? Are you going to use stones, particles? Are you going to use waves? Are you going to use a rope? Maybe the bowl that Einstein used, the canvas. And there's another way, and that's the Casimir way. And the Casimir way is that you remove particles between the puller and the donkey. Okay, and this is what you get. Okay, you have, this is the Casimir way. And what you have is, what you go in there and remove the particles that separate you from the donkey. Okay, and once you remove that, what happens is you have all these particles from behind the donkey and behind you, and those pull you together. That's the Casimir way. And they call it Casimir. He came up with that in 1948. Okay, he wrote a paper then. But the idea already came from Rediker and Kramer and Lesage. He's also given great merits for coming up with that, but Lesage got it from Fascio and Fascio from Lucretius. So all these people already had that idea of what is known as shadow gravity or shadow pull, where you remove whatever's between them and whatever's outside them pushes them together. That's the notion that Casimir came up with in his great mind, Yeah, and that's what they use today. Instead of saying, look, there's a physical object that's pulling, they're saying, no, we do it a different way. We remove whatever in between and, and the two objects come together. Okay, so that's in a nutshell general relativity. What is it essentially? It's a platform made, means the space, time, whichever one you want. There's this ether out there that they call space-time. In the case of general relativity, it's a mathematical contraption, which is four-dimensional, which is not really four-dimensional. What it is four number-lined, okay? Because mathematics doesn't have dimensions at all, or coordinates, or vectors. What they have is number lines. Everything has magnitude, and what they don't have is direction, okay, or perpendicularity, orthogonality, okay. And a dimension is exactly the opposite. It has orthogonality and direction. What it doesn't have, length, width, and height, what they don't have is magnitude at all. Okay, so that's essentially, what four-dimensional space-time is. The gravitational mechanism is that, you have simply something weighing down the canvas and the other object rolls around. You can't do it with three objects. You can only simulate it with two objects. And then they tell you, well, the analogy is worthless anyway, so we don't care about that. All they care about is the mathematics. And so if you care about understanding gravity and you want to ask the question, how does gravity work? You'll never find out from general relativity, because that's what they're going to tell you, and then they're going to deny it at the end of the story and say, well, you're not supposed to take the analogy. So literally, that's the answer you get. Okay, we have our science critic, and he also analyzed general relativity, and so it's on topic today. So let's see what he had to say about general relativity, okay, and space-time specifically. Here goes. Listen carefully. The questions and issues to be addressed in this rebuttal include: does GPS prove that general relativity is correct? Does space-time explain gravity? Does space-time have anything at all to do with physics?
Well, it's not so much that we wouldn't have developed GPS if general relativity was incorrect. It's more that GPS has to account for general relativity, because otherwise it won't work. And the difference between these two statements is that in the latter, if general relativity were false, we could still develop GPS, it just wouldn't have to account for general relativity. I know that you do not believe in space-time, but the curvature of space-time is the mechanism that causes gravity to occur. Or at least that is the best idea that we currently have.
The best idea the mathematicians have, that's space-time. And so one question with GPS is, the GPS prove that time is a physical object, that time can be warped, that time serves as the wall that prevents the Earth from flying out of the solar system, or the moon for that matter. And so that's the first question you should ask. Is that a valid physical interpretation? Does that make any sense to you? And if they say, well, you're not supposed to take the analogy so literally, and we don't care about physical interpretations, we just care about the math, well, then why are you asking a question about mechanisms to a mathematician, first of all? And second, why have they ventured into what they call philosophy, explaining the mechanism? Why have they even attempted that? Why don't they stay in math and say, look, these are the equations? And they can stay there with their description, no problem. It's when they cross the line into physics and say, look, our equations, we interpret them as this. Yeah, but your interpretation is ridiculous. It's not even worthy of consideration. We have to lock you up in a mental asylum if you come up with that interpretation. They say, well, you're not supposed to take it literally. Well, why did you attempt to do it in the first place? If your physical interpretation is garbage and you're gonna reject it at the end of your tale, at the end of your dissertation, why did you even attempt it? Why did you even try? Why are you trying to give a physical interpretation to begin with? Well, I'll tell you why. Because otherwise, mathematics, mathematical physics, is worthless. It's irrelevant if it cannot give you a physical interpretation. So they give you a description, then they give you their physical interpretation, their opinions, which are all ridiculous nonsense. And then they say, forget about our physical interpretations. We know because we do the equations every day, and the equations tell us this. So all they have is a measurement. They have a description. They don't have an explanation. And this fellow believes, like so many people out there, they're fooled into believing that general relativity has an explanation for gravity, a physical interpretation that warp space, warp time is what prevents the Earth from flying out of the solar system. They really believe that. They believe that space and time are physical objects. And again, that's the question. Does GPS prove that time is a physical object? And if it doesn't, then GPS is technology and has nothing to do with science. It has nothing to do with science. Science we have to explain. Okay, we have to explain why the GPS little thingy there rolls around the Earth. Why doesn't it fly out of the solar system? What keeps GPS, the probe with the gyroscopes, what keeps it rolling around the Earth? Why doesn't it just keep rolling out? Is it going around another space-time depression, its own? Dragging space-time around itself, as they say? So here's the problem with what this fellow says. Again, we have time, which is warped, and this fellow believes that it's these seconds that serve as walls to the Earth. We have time, bent time, warped time, curved time. Okay? And that's what prevents the Earth from flying out of the solar system. That's the physical interpretation. And then they tell you, well, by the way, don't take it literally. Then what have we learned if we're not supposed to take this literally? That time is a concept that prevents the Earth, a physical object, from flying out of the solar system? Jesus Christ. Okay, and so what's the problem? The problem is that time is not even a dimension. Okay, time is a number line. Time does not have direction. Time only has magnitude, and time doesn't go perpendicular to anything because it doesn't have direction. On the other hand, length, width, and height, in the case of dimensions, true dimensions, coordinates, longitude, latitude, altitude, and vectors like depth, breadth, and elevation. All these have perpendicularity and they have direction. What they lack, all of these, is magnitude. And number lines have the opposite, have magnitude, no direction, no perpendicularity. That's why the space-time, four-dimensional space-time, is really four-number lined, not four-dimensional. Okay? Dementia is what mathematicians have because they never define their terms. So they come up with nonsense as far as a physical interpretation for what's happening out there. That's the situation. Okay, we had some flat earthers, okay? And they had all kinds of problems understanding the question, and they still have problems understanding the question. They think they understood the question. They said, but we answered the question, Bill. And no, you haven't. You haven't even understood the question. So let's find out what they don't understand. And I'm going to go quickly through these. Here's the first one. Fellow says, fellow on the other side. Give me a second here. Here's the first one. Says, during acceleration, the air in the car has a higher density in the back of the vehicle than it does in the front. Remember, the balloon goes forward when you accelerate instead of backward, as intuition would tell you. And the idea is that all this air that accumulates in the back pushes the balloon forward. So the question was, why does the air go back or stay in its place while the car accelerates? No one understands the question yet. This guy just says, higher density in the back. Yeah, we know that. You have to explain why there's higher density in the bag, okay? It says, this means that the net force on the balloon due to collisions with the air will be in the forward direction. Yeah, that's what happens when people don't understand the question. They just repeat the same description. They say, well, air goes back and pushes the balloon forward. Yeah, we know that. So please don't answer what hasn't been asked, or don't answer with a description which we already understand, know, and have already put forth. Another fellow says, the balloon isn't pushed forward without a roof on the car. So he's saying that it's the roof that pushes the air, right? The car is the container. Yeah, we know that. Separating the system off from the outside. Yeah, we know that too. So it's isolated. So the motion of the container allows for the accumulation inside the sealed container. And again, it doesn't understand the question. The question is, why does the air accumulate in the back, when the car accelerates? Okay, it pushes the first few atoms or molecules, fine. And the question is, why are the other ones waiting? We're not concerned about the ones that are being touched by the car, the window, the roof. We're concerned about the ones that are standing still waiting for the car to reach them. Still didn't understand probably, okay, but that's the best way I can explain it to them. The question, this is 5 weeks now, I've been trying to explain the question. That's just unbelievable. Okay, and same fellow says, question, what is the mechanism to make air accumulate in the back of the car? Yeah, that's the question. Do you understand the question? No, he doesn't, because he says, the structure of the car and window does not allow air molecules to transmit through it. No kidding. Did you figure this out all by yourself? You must have had help. I don't trust people. They get help. It's a structure of glass preventing an oxygen molecule from passing through it. This is what they answer. That air cannot go through glass. That's why it accumulates. Okay, same fellow. He goes a little further. Okay, he says, why does the air molecule stay where it is? Yeah, that's what we want you to answer. Okay, it says the structure of the atmosphere where there are trillions of other molecules holding the total system in place until a force disturbs it. Physical mechanism, structure of the atmosphere similar to being in a child's ball pit with extremely tiny balls. So he's saying one of the two. It's either the glass of the back of the van that's pushing the molecules forward, or that it's the other molecules that are pushing the molecules forward. So he hasn't answered he doesn't even understand the question yet. 3 times. He answers 3 times. He never fixed the problem. He doesn't understand the question. This is 5 weeks that this fellow doesn't understand the question. No, the question is, he asked the question, but he doesn't understand what he's asking. What the question is. The question, why does the air molecule stay where it is? Okay, so you have some molecules that are being touched by the car as the car accelerates. Meanwhile, you have other molecules that are waiting for either the molecules or the car to smash against them. Why are those molecules that nothing has touched them yet, why are those standing still? Why are they still in place? Why haven't they moved? I mean, they move a little bit. We all recognize that. They move a little bit, but they don't move at the speed of the car. The car is squashing the molecules that are closer to the window, and they're pushing them all together. So that's why the density accumulates. But until the car runs, we have some molecules which are standing still or moving back. Some people believe that they move back. We're going to argue here that they stand still. Okay, so we have molecules pushing, but some are standing still until what they say, a force. No, there is no such thing as force. No physical object called force. Until the back of the car or other molecules of air push them. Okay, but until that happens, these molecules are standing still, waiting for something to hit them. Why are they standing still like a tree stuck to the ground? That's the question. 5 weeks now. They still don't understand the question. And I'm not sure they still understood it yet, And a fellow says, couldn't it be the walls of the car hitting an air on all sides? Same thing. These people are saying the walls are hitting the molecule. No, the question is, why are the molecules standing still until the wall hits them? Okay, so they don't understand the question. It's unbelievable. These people are mentally retarded. They don't understand the question. And yeah, they just have this second nature that they say, well, it is so. The molecule's there until something hits it. A force, they say, a force. It could be a horse, maybe. Maybe that's what they're talking about. There is no physical object called force. So why these people use the word force, I have no idea. There's no such thing as force. No such thing as density. No such thing as gravity. Okay, you have to identify the physical object that comes in contact with the molecule. And it could be other molecules. It could be the glass or the back of the van. That we can accept. You can say the back of the van, the wall, the glass hit the molecule. That we all understand. And you can say other molecules of air hit the molecule of air that was standing still. We can all understand that as well. The issue is until something hits it. Why? What keeps that molecule standing still? And people think that, well, it should stand still until a force hits it and moves it. Not true. You have not justified that. You're just repeating stuff that you don't understand. Okay, you're just saying it is so. That's all you're saying. There is no reason for a molecule to stand still. Now, in the case of the tree, you say, well, I know why that stands still, because it's stuck to the ground and it's a rigid entity essentially, so the tree doesn't move with a car, especially if, like I showed the couple weeks ago, you build the van on top of the tree. So the tree is inside the van, right? So it's inside the van. It's not touching any part of the van. But when the car or the van accelerates, the tree is left behind because it's stuck to the ground, even though it's inside the car, just like the molecule. But the molecule is inside the car. It also stands still, just like the tree. In the case of the tree, you say, well, it's because it's stuck to the ground. So is the molecule stuck to the ground also? That's the question. So fellow says, the question you're asking about why objects stay behind is not related to the container moving. Finally, one person who understands at least the question. Yes, the container has nothing to do with the whole question. So don't tell me the container, and don't tell me that the molecules that have bundled up in the back of air, that they're going to push the molecule. Forget about all that. You have to tell me why that molecule stands still until something hits it. That's the question, if you can understand it. Why doesn't the air spontaneously move to one side of the container? Because on average, the summation of random motion is 0. So this fellow is saying, yeah, it stands still and it's got nothing to do with the container. Okay, great. We understand that. That is, you got a little head start over the other fellows, okay? But how does he answer? He says the average motion. That's not a question. That's not an answer. You can't say it's the average motion. That's mathematics. We need to know what physical object either keeps the molecule in place until what other object hits it and moves it. Okay, so the question is why? What causes the molecule to stand still? You're making an assumption that it stands still, but you're not telling me what causes it to stand still until something hits it. And you just take it for granted. Well, it stands still until something hits it. Not true. Absolutely not true. Nothing stands still in the universe. Okay, so you got to tell me why it's standing still until something hits it. And if you take it for granted, you're making the wrong assumption. You're making an irrational assumption. Okay, so that's the issue. Okay, so here we're going to illustrate it one more time. Maybe someone understands it finally. Okay, here it is. Here's the pencil. Okay, and you can see the pencil doesn't bunch up at the back of the van. In other words, all the atoms do not, or molecules, they do not create higher density in the back. Why? You say, well, it's because it's a rigid entity, so all the molecules, all the atoms of the pencil move at the same time. Okay? And again, it's got nothing to do with the pencil going through the window, like some people say out there. Okay? So you can see the atoms are being pushed all simultaneously, and you say, well, because it's a rigid structure. That's why you say, that's why they all move forward at the same time. Okay, but here we did it with water the other day. Okay, we moved this rapidly, water in a container, and you can see that there's going to be a gradient of water, and it's going to accumulate in the back. There it is. Okay, very quickly you can see the water moving towards the rear of the container there, and you can see there's this gradient of water. It all moved backwards. Okay, so the question, why did all that water accumulate in the back? That's the first question. But the real question we want to understand is, why did water stand still, the water molecules, until the back of the container hit it or other water molecules hit it? Okay, that's going to be the question. Let's see if we can understand the question. Okay, and here it is illustrated. Okay, we're going to accelerate the van, okay? And you can see some molecules stay until something hits it. Until something hits it. The question is, why until something hits it does it stand still? Okay? Because we can all understand the back of the van hitting molecules and piling them up. We can all understand that. We can all understand why molecules of air are hitting other molecules of air and bunching up. Those part we understand, that is not the question. The question is, why do the ones that say stays, why do they stay? What keeps them in place is the question. Okay? That's the question. I'm just trying to get people to understand the question. So let's stand still. Let's force this thing to stand still. Here it is. Okay, you can see the three molecules in the back are being bunched up, while the other ones are still in their normal state essentially. Okay, until either a molecule of air or the back of the truck hits it, that molecule stays in place. We want to understand why the molecule stands in place, what keeps it there. And don't tell me it stays there until something hits it, until there's a force, because it means you have to go to see a shrink. Okay, you got mental problems. You're making an assumption that is invalid. Okay, so you cannot say the molecule stands still because. No, everything is caused, and standing still also is caused. That's the issue. Okay? How do we explain with a rope? Very simple. We explained this in the past. The molecule stands still because that molecule is stuck to every atom on Earth. Every atom on Earth is stuck, is pulling on that molecule. That's essentially the reason it stays more or less in the same place until something like the truck hits it, or another molecule, set of molecules, air, bunches up and pushes out. Pushes the molecule forward. Okay, and here you have Mr. Muller again, just in case. So, for example, if you have the Earth, there's a big mass here, and you have you with your little mass here. Every atom on Earth is pulling on every atom of you. You're also pulling on it. Please repeat this every night as your prayer. Every atom on Earth, okay, is pulling on every atom of you. You're also pulling on it. You have to memorize that mantra because you're not understanding what this man is telling you. Okay? And until you understand that, what he's saying there, every atom on Earth is pulling on every atom of you, and you're also pulling on it. Unless you understand what that's telling you, you won't understand why that molecule stays in place. It stays in place because every atom on Earth is bound to that atom, and that atom is bound, pulling on every atom on Earth, so it more or less stays in place. That's what keeps it in place. The assumption that you have in your tiny little brain that until a force pushes it stays there is irrational. That's what's irrational. Okay? And it takes a long time for these mental cases to understand that. Flat earthers. Okay, fellow says, according to your rope hypothesis, the air molecules are connected to the container as well as the rest of the universe. Yeah, correct. When the container accelerates, there should be a small net force, assuming shorter ropes have more effect than longer ropes. No, they don't. Accelerating the air molecules in the direction that the container travels. Conventional science does not support this. Yeah, neither does the rope model. Because again, this individual does not understand the rope model. He hasn't done a minimum of research. Here's our version. The atoms slide along a rope as they eat into the rope, link by link. Okay, so an atom moves like a bead on an abacus. It slides without dragging the rope behind it. The ropes are always taut. They're pulled tightly between any two atoms. Pulled by every atom in the universe. That's why it's so tight. The speed of light is a measure of that tension, and the speed of light is constant. That's why it's a constant tension. And all you have is an atom just sliding along the ropes. Why? Because the atom is made of those same threads. Okay, there's a single thread in the entire universe. So until you understand the foundations, the basics of rope model, you cannot even, come up with these scenarios because you don't understand enough about them. Okay, and then final issue related to the van and to the air. Here it is. Fellow says, if we can ignore the effect of gravity, do the air molecules follow a straight path relative to the Earth or a curved path influenced by the acceleration of the container? In other words, he's saying, if the van pulls all or drags or pushes all these molecules of air, do the molecules stay straight or parallel to the Earth, or does it go in the direction in which the van goes? So if the van goes on a curve, the air molecules still stay straight and the van just goes sideways? That sort of thing. That's what he's asking. And so he continues, he says, therefore you have the basis of an experiment to test the validity of the rope hypothesis. Well, the first thing is that in science we don't test anything. We don't prove, we don't verify. Okay, we don't do any of those things that they do in mathematics, because we're talking about invisible, intangible entities. There's no way anyone can prove to you, can verify for you through see or touch, through an experiment, create some evidence for you that the rope exists. Okay, the rope is invisible and intangible. In fact, atoms, individual atoms are invisible and intangible. You can't see a hydrogen atom. Okay, so you can't see or touch. You might touch it, but you won't know. So you say, did I touch it or not? You won't know. You won't know if you touch the hydrogen atom. Okay, so prove to me that you touched the hydrogen atom. You touched the table which contained a hydrogen atom, but I don't know, maybe you touched the carbon atom or who knows what. We don't know that you touched the hydrogen atom. So you can't see or touch an atom, let alone the rope, which is gazillions of times thinner than an atom. Okay, so forget about see touch. You're talking about something that's beyond the Planck length, okay, or Planck width or Planck energy or whatever. There's no way to see or touch that. It has no ability for a human to see or touch the rope. Okay, so no experiment, no evidence. You'll never find evidence. This is something that you conceptualize, you visualize, you imagine. Okay, so you can't see or touch it. Especially because it's invisible, intangible, and meaning that if you have that notion of the word object, you have an irrational notion of the word object. Not all objects can be seen, not all objects can be touched. And so the question for you, are there noumena? In other words, like phenomena means the stuff that you can see or touch. Noumena are stuff that you cannot see or touch. And again, these are like, who was it? Trying to remember the philosopher who said that it's an object of the mind. You can only conceptualize it, you can imagine it, you can try to visualize it. That's it. So that you understand how the universe works. That's where it goes. It has nothing to do with going to the lab and touching and seeing. So you will not determine this through an experiment. Anyways, the car, the container, will take the air with it. Okay, so he asked there, if the car accelerates, what will happen to the air? Will it go straight or curve with the car? It's very simple. Why does this person have so much problem? This is very straightforward. The car will drag the air with it. Okay, just like I'm dragging this wand with my hand because I'm pushing against it. Well, the same thing with air, no different. So these people have, I don't know, really big problems in their minds. They're irrational folk. They're probably, again, flat earthers and electric universers. Okay, let's go with the questions that people asked, comments that people made since last time. Fellow says, Operation Mockingbird is working well. The moon landing discussion devolved into debating flat earthers, and no one even noticed the transition. What was Operation Mockingbird? Well, that's an alleged large-scale program by the United States Central Intelligence Agency that began in early years of Cold War and attempted to manipulate domestic American news media organizations for propaganda purposes. I don't know. That's never ended. Hitler did it. The United States does it. Russia does it. China does it. All mafias do it. So I don't know why they made such a fuss out of Mockingbird, because we've been doing Mockingbird since the days of Julius Caesar. Okay, it's always been there. Get control of the press. I mean, look at what's happening in Ukraine. In the West, we receive the information the United States wants, and in the East, they receive the information the Russians want. And what have we learned? So don't pay attention to any of that, because it's just propaganda, all of it, 100% of it, 150% of it. But anyways, just to answer this, no, it's not that we're doing a Mockingbird here. It's that, no one raised any more issues on the Moonies, on, the moon landings. Nothing new. No one was able to address the issues that are raised. And the issue that I raised was primarily you have this thing that everybody can verify out there, which is the International Space Station. It's rolling around the Earth every 15 times a day, every 90 minutes. You can find the schedule in the at NASA's site, and you'll find the schedule. You can get your binoculars, your telescope, and you can look at it. And if it's out there, and you'll figure out, if you got a mathematician close to you, he can figure out for you how big that thing is. And it's the size of a football field. And so here you have this object the size of a football field that you can verify with your own eyes. How did it get up there? Was it just one day they had a headache and they said, let's send this thing up there? No, it took many projects, a series of developments to put that thing up there in the sky. And in fact, in the case of the ISS, it took 10 years to build it piece by piece through the space shuttle and other organizations that contributed to it. And so it took a long time to build that. And if that thing is up there and it's rolling around the Earth, something you can verify, if you don't believe in that, forget about the moon landings. I mean, here's something you can verify by yourself. You don't need the NASA, you don't need the United States government or anybody fooling you, Here you can verify for yourself. And all you need is a telescope or a pair of binoculars. It's very simple. Just go ahead and do it. And once you verify that, if that thing is up there, well, now you got a problem because you say, how did that get up there? Why is it still rolling around the Earth? How did they do that? Here's a monster going around the Earth. And then the issue there is, are there people up there? And yeah, these people say, they film how they go up there and they do all these little tricks. And they have a million questions on those. How they drink water so dangerous, nonsense. And so these people are in low gravity, and so they float around. And so, yeah, we do have a vehicle out there in which people float around daily because they do their work. They're called astronauts, and they go out there and they test different things, And so, if we can do that, if you can at least accept that, then it'll be easier for you to understand that we did go to the moon. Okay, and all the arguments that people raise against the moon say, look, the stars in the background, the gravity is not right, and the shadows are not right, and they go through all this stuff. And they say, well, that was produced in a Hollywood studio. And the answer is yes. Okay, let's go with that. Tell me, this is the question for you. Can you tell me, right, that it wasn't done in Hollywood? Can you tell me the difference between doing it for real and doing it in Hollywood? I mean, if Hollywood can do it and could have done it in 1969, right? Let's go all the way here, right? If Hollywood could have done it in 1969 and that was all show done here on Earth, can you tell me what the difference is, how you would tell the difference between done in Hollywood and done for real? If you can't tell me the difference, you can't use the argument that it could have been done in Hollywood. You can't use that argument because you can't tell me the difference. That's how simple that is. And that's one issue. The other issue is that, a lot of that technology, Hollywood technology, came later. Okay? People will say, well, so did the moon landing, all that stuff came later, but again, I say that the Russians would have protested, Soviets. They would have said a lot about the United States being the first to be on the moon. And just like the United States would have said a lot about Gagarin being the first guy to orbit the Earth and Tereshkova being the first gal out there and Laika the first dog and so on. The United States could have said that never happened. Okay? Now, you can say, well, they did it for propaganda to get the ball rolling in the United States so that everybody would get on ball with a project, with the NASA project. Yeah, you can come up with a million arguments. My argument is that the Russians would have said that never happened. We verified that these guys never went to the moon, etc. And the Russians never did that. And they could have said that to their people, and they never did. Okay? So just keep all that in mind. The way I look at it is these people would not have accepted that the United States went to the moon if they really didn't. Okay, another fellow here says everything already existed 13.8 billion years ago. It talks about a static universe, energy that we see. We see energy. Man, you got good eyesight. Okay? He says, universe created quark plasma shrapnel. Where did he get all these words? He get them from the establishment, which he talks against. He says black holes are made of quark plasma, whatever a quark is, whatever plasma is. No such physical object. And again, talks about energy. That's what it is. All these ignorant people, they come out here and they bring all this language from the mathematical establishment. They think they're scientists. I mean, why don't these people just stay in church on Sunday and just leave it at that, you know? Now the fellow says, surely the singularity must be infinitely large, talking about, you know, the Big Bang singularity, or it could be the black hole singularity as well, to anything within it. Okay, so here's infinitely large to anything within it. I don't know how that can be because they say it's infinitely small, so I don't know how you can fit infinitely big with respect to something inside it, but he's saying anything within it, okay? If everything is within it, as it has no boundary, right? There being nothing outside of it, being infinitely large, it cannot expand into anything since it's already infinite. No such thing as an infinite object. It has to expand against something no matter what. Okay, you can't say something is so big that it's infinitely big. No such monster. Either it's an object, which means it has shape, means that you can visualize its finiteness. You know, in other words, essentially, right? An object is that which is finite, and you can't say an object that is infinite. No such thing. Are you saying it's growing constantly and you can't see the edge of it? You cannot even imagine the edge of it or what it looks like from the outside? That's not an object. An object is that which you can visualize, okay, completely. And that means something's got to be on the outside of it, no matter how you see it. And so, yeah, his argument is total nonsense. Okay? And again, these people try to get around it, you know, with these, you can call it logic, I call it illogic, and they think they can get away with it. You know, saying, no, it's a finite, infinite object. Well, which one is it, finite or infinite? You know, if it's finite, it's got shape. If it's infinite, it's not an object, because an object is that which has shape, which is finite. Period. We're done. It's got to have something outside of it. Okay, fellow says, actually, science is a subset of philosophy. Not true. It looks like philosophy looks like it's a branch of science. Science is rational explanations. Physics explains causes and mechanisms. And philosophy explains reasons and purposes. Okay. One deals with object, the other one primarily the bread and butter is the concept. Okay, so yeah. Another philosopher comes over and he says the following. He says, allow me as a philosopher to explain how this works. Whoa, okay, we got a philosopher. Do note this is philosophy, not science. Again, philosophy is a branch of science. Hopefully, anyone who touches the word philosophy is going to explain something. Explain, in the case of philosophy, is going to explain a behavior, a purpose. Okay, the physical cannot exist. What's that got? What does exist have to do with philosophy? No such monster in philosophy. Philosophy doesn't deal with existence. Physics is the science of existence. Okay, without the conceptual as exist, the action exist as an action. He says the physical cannot exist without the conceptual as exist. The action, right, is conceptual and is a prerequisite to the prior being sensitive. Yeah, exist is not an action. Exist is a static concept. Okay, exist is actually an adjective in physics. It qualifies an object. It gives it location. That's what it is. There is no motion, so it's not an adverb. It's an adjective. Exist is an adjective, not a verb. It's a verb in ordinary speech. So you can say, I began to exist. That's in ordinary speech. You can't begin to exist in physics. In physics, what exists, exists. And that has to be an object first and has to have location with respect to everything else. And so he says the prerequisite for exist cannot be anything other than what functions prior to existence. The problem is a thing prior to existence cannot exist and hence cannot cause existence. Therefore, existence is a necessary self-proving value. That is to say, nothing is prior to existence. This is not a unique property. Well, obviously, this fellow is not a philosopher. He's a retarded individual. That's what he is. These people call themselves philosophers, and they're not philosophers. They think philosophy is, oh, it's his way of thinking. No, no. If it's his way of thinking, we've got 8 billion philosophers on planet Earth. Okay? And there's no difference between Aristotle and you. Why do you call Aristotle a philosopher if you're a philosopher and everybody else is a philosopher? If it's just a way of thinking. So hopefully philosophy is not just a way of thinking. Okay? Philosophy, you have to explain something because it's a branch of science, and philosophy is the branch that explains behavior, explains specifically purposes and behavior, reasons why someone does something. That's what philosophy is. Anything other than that is not philosophy. Other than that, what you have is opinions. Okay, people have opinions, recommendations, politics, religion. None of that is philosophy. Okay, but that's what has been mixed or blended in with what these people call philosophy. They say, I'm a philosopher. Who knows what he studied? Studied garbage in the university. He calls himself a philosopher. And he continues, he says, the assemblage of all these necessary self-proving values cause all things, and hence can be said omnipotent, which is the primary trait of God. Yeah, God is alleged to be omnipotent. Hence, God hence does not cause the physical and is necessary in complete explanation of all items. Okay? The flaw to the requirement of the addition of God is that we are concerned with physics, and God is not physical as found prior. Well, God looks like he's physical. There's God. He looks pretty physical to me. And even his angels, the one up there is known as Bill the angel, carries a baseball bat in his hand. All those are objects. All those are things. So I don't know what he's saying that it's not physical. They're all physical. Physical, that which has shape. That's the definition of the word physical. So I don't know what he's talking about. And again, it's because he doesn't define his terms. He doesn't define what physical is, and he doesn't define what exist means. So he gets into these ramblings. He goes around in circles, and they call themselves philosophers. They're nothing. Absolutely nothing. They're just like Ayn Rand, who kept going around in circles also, thinking she was a philosopher. She couldn't define exist, and she certainly couldn't define entity, as she called it. Made a mess of all that. Again, she introduced see and touch and experience and, contact. Okay, fellow says, thought experiment for theists and atheists. Okay, let's see what this is all about. Advanced interdimensional aliens land on Earth, okay, and we ask them if they evolved or were created. And they say they have always existed. Do you believe them? If not, why? Okay, so we have these interdimensional aliens. Okay, they come to Earth and they say they've always existed. And you're supposed to say, well, hold it, you weren't created, or you didn't evolve, or what? Which is true? Or they always existed? How should we answer that? Okay. Well, I'll leave it as homework. I want people to try to give it a shot. I want to see what kind of answers we get. So try to see if you can get the interdimensional monsters to give you a hint whether they always existed, were created, or evolved. Okay, another fellow says, I agree that a wave is a concept. Well, I don't know if you agree because you don't know what a concept is. You haven't defined it, but it can be explained. Okay, so wave can be explained. Eric Laithwaite did so in his video. So he pointed me to a video, and people sitting in stadiums do it. The wave with their hands, right? I call it the transfer of information. He transfers information. How do you transfer information? I don't know how you transfer concepts. How do you transfer data? How do you transfer intelligence? How do you transfer love? I mean, you pick it up with tweezers, and that's how you transfer information? Rather than energy, since the energy stays. Oh, the energy stays. I'm wondering how many drinks this guy had, Bartender, I'll have whatever he had. Energy stays. How does it stay? How does it leave? Energy is a concept. So is information. You can't make it stay. You can't make it go. You can't transfer it. You can't kick it. You can't do anything with energy. But if you think you can, please draw it first so that we know what you're kicking, what your feet comes up against. Okay? And he says information is a photon. Whoa. Photons are mass-free since information is merely an abstraction devoid of mass. Yeah, there's no physical object called information, no physical object called mass. So this guy's just spinning his wheels. You know, we don't know what he's saying because he doesn't define any term. He thinks people understand it. But let's get back to the Leitwaite. Okay, this is what Leitwaite did. He made a simulation of what a wave is, the transverse wave, supposedly, you know, of quantum mechanics and mathematical physics in general. And he shows how the wave can move something forward or backward. Okay, and the way he does it is by putting it inside the wave. Now, what's the problem with this that Leitwaite never figured out? And that is that we don't know what those waves are. In other words, what's the physical object that mediates the wave? And of course, he'll never tell you that. No mathematician will. They'll tell you something stupid like, you know, it's the undulation of nothing. And then the other one is that the wave, he says, is pushing the ball. And so this is the explanation this poor fellow accepted. You know, he doesn't realize how much nonsense he's staring at. Yeah, he just likes the pretty picture of Leitwaite just moving the little bar up and down and causing the waves and pushing the ball. He likes the art, the entertainment. You know, that's nice, that's beautiful. No explanation whatsoever because we don't know what a wave is. We don't know what mediates the wave. What is the mediator of the wave? In the case of water waves, you know, the ocean wave, we say it's water. In the case of the flag, we know what its flag is waving. It's the flag, the piece of cloth. Okay, so what is waving in the case of transverse wave, light waves? You know, any of those waves? We don't know. We have no idea. And until Leitwaite identifies those, he can't even start his presentation. All he did was entertain you. Hasn't explained absolutely anything. One other fellow says, and yet without math, you would still be a prehistoric man. Okay. Because all the technology that we use today rely on math. Is that so? Okay. Well, technology is not equal to science. So even if math has something to do with technology, certainly math has nothing at all to do with science. Okay. So he hasn't said any. He hasn't addressed the issue. Technology is developed by trial and error. That's how we come up with technology. And the best case is Mr. Thomas Alva Edison. He said, I have not failed. I've just found 10,000 ways that won't work. He tried one thing after another. Did he do any math? Did he do, in fact, the guy who criticized him was Tesla. He says, you know, Edison is such a dope that if he had to find a needle in a haystack, he would not stop pulling, you know, straws until he found a needle. That's the way Edison worked. He was just a hard worker. And he said he could have saved a lot of time if he would have done a little bit of math and calculations and maybe come up with, you know, the right place where the needle could be. Now, that was Tesla's assessment of Edison. And remember, Tesla worked for Edison until he jumped ship and went to work for Westinghouse. Anyways, there you have it. That's a synthesis of what technology is. Trial and error. You try one thing, it doesn't work, you try another one until you get it better. And then you got to understand that math is developed from measurement. It's not the other way around. Okay, it's not math came first and they predicted the behavior. No, they looked at the behavior, they zeroed in with the math, and then from then on they can say, well, now we can predict how this is going to behave because we already looked at it so many times. We tweaked the equation so much that now it's a tautology. That's what mathematics is, just tautologies. Because measurement is a tautology. The equation just reflects the measurement. So it shouldn't surprise you that they say, oh, the equation, we predicted that this was going to happen. No kidding. No kidding. You measured 1 billion times and the prediction had better come true, you know. Anyways, it's got an unsubstantiated statement. He said, because all the technology that we use today rely on math. Well, can you give me some examples? I mean, you put no example, you just said all. And here I'll give you an example that doesn't work, that certainly goes outside your claim there, and that is that Iran has math. He's got the best mathematicians on earth together with everybody else. Yet Iran doesn't have the bomb. Okay, so here we have technology. They have the math, but they don't have the technology. So I don't know. You got to think about all that. Okay. Okay, last guy over here. Last one in. Last question, last comment. Person says, geocentric analysis, please. Another flat earther, I guess. He believes that geocentric, meaning, you know, the Earth is the center of the universe or the center of our solar system or whichever, and everything rolls around us, okay? And so here's the flat earth version, I think. I mean, I don't want to put words in their mouth. This is the way I imagined their stuff, okay? You have the sun, and it rolls around, I guess, or slides around the Earth. And I do want to apologize that I didn't put the Arctic ice around the Earth. I had no time, so I hope you forgive me for that. And then we have this, okay, in comparison. This is our version of it, okay? Not the Earth, but the sun is at the center of our solar system, which is not the center of our galaxy, which is not the center of the universe, okay? But here you have why the Earth, you know, rolls around the sun, because the sun pulls it or swings it around by all the ropes that connect every one of the atoms of each object, okay? And so here we have also, as part of that, you know, the fact that the Earth is round and it curves the water around itself. Why? Because every atom on Earth is bound to every atom of the air and every atom of the water. So all atoms of the water, right? Every single atom is bound by electromagnetic ropes to every atom of the Earth and to every atom on the other side of the Earth. So everything pulls inward. That's why it's more or less a sphere, the Earth. And the air is also a shell that encapsulates the Earth. Why? Because every atom of the Earth, of air, like you see there, is tugged or pulled, or really there's tension. I hate to use the word pull, but everybody understands the word pull. And so it's pulled towards the center of the Earth, and so everything converges upon the center. That's the issue. And so, yeah, what can we say? We have to say that we have a geocentric solar system, but we don't have a sun-centered solar system, not a geocentric solar system. And the sun is not the center of the galaxy, and the galaxy is not the center of the universe. We're just a tiny speck of dust going around the sun, which is a star going around the Milky Way, you know, our galaxy, which is going who knows around what out there. Okay, we can't see everything out there, but we know we're rolling along. Okay, we're moving, and you don't see any movement, you don't feel any movement. Well, maybe you haven't drank enough beer. Just one note, and that is next time I've got a conflict of schedule on next Sunday, so I'm going to have my next lecture on Monday. So I think it's the 21st. It's going to be Monday the 22nd. Okay, so don't be surprised when you see that. I just got a conflict of schedules.